Thanks everybody for coming. It's great to be here, great to see you after 2 years of, I don't know, just working at home and not seeing anybody. It sure makes a difference. I'll start like real simple. How many of you have heard of Quarkus? Okay, that's like almost everybody. How many of you have used Quarkus? Fair amount. Okay, so I'll do a small amount of explaining what Quarkus is before we actually get into some demos and explain some more advanced stuff. Okay, so what is Quarkus? Quarkus is a stack to write Java applications. What kind of Java applications? Basically cloud native applications, microservices, serverless. So it's very analogous, let's say, for those who have not used it. It's very analogous to what you probably have used with Spring Boot or a framework like that, right? So we target this kind of like new era paradigm of applications. And basically, we have a whole host of solutions for building, to enable all of you to build distributed systems, right? Because at the end of the day, that's what microservices really are. They're distributed systems, and you have to address a whole bunch of problems in order to get things right. And obviously, a framework can do a lot of work for you, eliminate a lot of boilerplate, enable you, give you the option to opt into like some patterns and things like that. So there are four, let's say, tenets that Quarkus tries to follow. We've been saying this from day one, but I'll just reiterate here. I'm not going to go into much detail about what these are, but I'll say developer joy. You'll very much see this during the demo that I'll attempt to do. We are very much focused on making all of you as productive as possible while you're writing Java applications, right? We want you, when you pick up Java and when you use Quarkus, to get your job done really, really quickly and feel great about yourselves. We don't want you to be bogged down with working with like arcane APIs and things like that, or taking like a whole bunch of time to reload your application or run tests. So that's one part. The other part that most people have heard of Quarkus for is what we call Supersonic Subatomic Java. That's basically just a marketing term for saying that Quarkus takes up very few resources, both in terms of the memory used and how fast it starts. Third part is we incorporate as many of the libraries and frameworks that you already know as Java developers, because as Java developers, like one of the super great things about the Java ecosystem is that we have a whole bunch of libraries and frameworks that we can use to be productive. And we've tried, and I would say done a pretty good job at incorporating as many of these as possible into Quarkus and make the developer experience using them really great. And fourth, and very important to folks that want to achieve maximum performance and the least amount of resource usage, is that we provide a unified API for both reactive and imperative programming, right? So if you really, really need to use reactive programming, we provide, which reactive programming everybody knows is extremely hard to do, but we try to make it as easy as possible, and I'll show that in the demo. But again, you don't have to use reactive programming. It's there, it's optional. You can use it if you want to, and we'll see how you can do that. So what is Quarkus? Basically, if you have to like distill it down to two things, we would say that it's a framework where it moves a whole bunch of processing to build time, and it also builds on reactive principles. This slide is basically a very, very simplified way of showing like what the technical difference is between Quarkus and a different framework, a traditional framework like, let's say, Spring Boot or something like that, right? So with a traditional framework, at build time, you basically don't do anything, right? All you do is like a Maven package or a Gradle build, and that doesn't do much. There's no logic in there. All it does is build a jar or a war or whatever. And everything the framework needs to do is done at runtime, right? So in like scanning annotations, parsing configuration files, all that great stuff is done at runtime. Now, that was great for a few years. It enabled us to be really productive, but there's a better way. And there's a better way to enable, to make things better, both for the developer, yourselves, and the people that actually run the applications in production that so they don't complain like you have a CRUD application and it's taking 1 gigabyte of memory. Why is that? I mean, what is it doing? The solution to both of those problems is that with Quarkus, we move as much of the processing as we can to build time, right? So when you're doing an NVM package or a Gradle build, what Quarkus does, like let's say a really high level, is that we scan the entire class path of your application. We look for all sorts of annotations. We parse all sorts of configuration files. We build up a huge amount of metadata. We generate a lot of code. We transform some of your code, and we create an optimal jar that when it's run at runtime, that means that all this work is already done at build time, and it doesn't have to be redone every time the application starts, right? This, again, results in the application starting much faster and taking up a lot less memory, both because it has to do less processing and because it has a lot fewer dependencies at runtime, right? So let's say like with Hibernate, right? If you were parsing like persistence XML, that means with an old school framework, that meant at runtime you would have to have like XML parsers hanging around for the only reason that you were parsing an XML file. With Quarkus, you don't need that, and Hibernate would just run at runtime without having any XML dependencies, which obviously means that your metaspace, your JVM metaspace, would be much smaller, which in the end, that makes a big difference. The other thing that we're not going to show here, but you've probably heard, like folks that have heard Quarkus even in passing know that it enables the transformation of your Java application into a native binary. So that's like a Linux elf, something that doesn't need a JVM, by making GraalVM usage very easy, right? For the folks who don't know what GraalVM is simply, let's say, like a compiler that takes a Java application and compiles it down to the native binary. That is very hard to do if you're not using a framework like Quarkus or, let's say, Micronaut or Spring Boot. They're coming out with this sometime soon. So Quarkus makes it very easy to do that. But again, it's opt-in. Most people will just opt to use JVM instead of a native. And we're not going to see native today. There's a whole bunch of talks you can see about that. Now, very quickly, how much faster or smaller a Spring Boot application, a Quarkus application is versus like an old school application. If you're using a hotspot or regular JVM, we have seen in practice that, like compared to other frameworks, you're probably going to have about half the total memory usage, so total RAM usage, and you could see up to like a 5-time speed up when your application actually starts up versus these frameworks. That's for JVM. If you take the optional step to go to native, then things get like even more crazy. You can see like a fifth of the entire memory usage, and like 50 times speed up means that a lot of times your application is going to start in tens of milliseconds instead of, let's say, 2, 3, 5 seconds. You've probably all heard all that stuff. I just did a quick introduction for the folks that maybe needed a memory refresher. So let's see what we've done since about, say, April here of 2020. I think in Greece, like the lockdown was like March 2020, but I'm going to say April here to see what we've done. We have more than 50 releases. It's probably more like 70 or something like that. So we were releasing new minor version every month. And we also had like patch releases for bug fixes in between. So 24 minor version releases, 1 major version. So we bumped from Quarkus 1X to Quarkus 2X because we had various breaking changes there. They warranted the changes. And in terms of functionality, we've added tens of new extensions, so a bunch of new functionality, and we also made like a hub where all of you who are interested in creating Quarkus extensions can do so very easily and publish them and make them available in a super easy manner to the whole Quarkus community. Now, I'm going to go through like a list of some of the most major features that we added. We'll see, hopefully we'll see some of them during the demo. Dev services, basically this is that we have an integration with test containers, an amazing, I would say, integration with test containers, both when you're running the application and when you're testing your code. We'll see that in practice. REST Easy Reactive, basically we rewrote our JAX-RS implementation to work with with Quarkus build time principles, and to work with a reactive core instead of a blocking I/O that we had. And that also enabled us to expose the next thing, which is Hibernate Reactive. So Hibernate, as you all know, has been around like 20 years, probably the most popular library in the Java ecosystem. Now it has a reactive version. So now with REST-easy Reactive and Hibernate Reactive, as we'll see in the demo, you can create applications, real-world applications at a very, very high level with the APIs that you already know, and stay on the reactive route all the way. So no blocking I/O, which at the end of the day results in you being able to achieve higher throughput. Now, Dev UI, we'll see that. It's an amazing console that gives you like a view of the internals of the Quarkus application. Continuous testing, I'm not going to spoil this. I'll show you in the demo. Now, gRPC, GraphQL, and Function as a Service Framework, these things we are not going to show, but they're pretty much evident what they do. gRPC, GraphQL were very much requested from the community. I think we added those in the beginning of 2020, and they've continued to evolve, and they're used a lot. Now, a function as a service framework, we have an abstraction layer on top of like the various APIs that the cloud providers, the major cloud providers provide, and it's very easy to use. And finally, one thing that like we had been hassled by a ton of people from the Kotlin community. They wanted to use Quarkus, but they also wanted all the Kotlin cool features, right? So Kotlin coroutines, everybody was asking for Kotlin coroutines. I think it's like probably like one of the most asked features. So we provided support for that, and we'll hopefully see that in the demo as well. Now let's get to the demo and see what some of this stuff actually looks like in practice, right? So what we're going to start with is my objective here. I think you can see it, right? Yeah, it looks good, I think. My objective here is to show you, to build something like a to-do application, right? So something like this, which is simply it reads from a database and it updates like a to-do list, and it deletes and adds and things like that. So this is the idea, right? You want to build this. We're going to try to build it both with blocking and non-blocking APIs. We'll start with blocking, so really, really easy. And along the way, I want to show you some of the development features that we have in Quarkus, right? So let's start out. I'll make sure that I don't have any residual code lying around. I'll go Quarkus Dev, right? So we'll enter the Quarkus Dev Mode. The Dev Mode is the special mode we have in Quarkus that enables a whole bunch of features that make it very, very easy for you to code your applications. Now, what kind of application am I building here? Oh, sorry, I'm using the wrong dependencies here. So let's go and start and say Hibernate ORM and JDBC. So I want a blocking style API first. So I'm going to use JDBC. Oops. And we'll get to reactive once we're done with the blocking stuff. So we'll start like this. Hibernate ORM, so the traditional Hibernate you already know, JDBC drivers under the hood, and we'll develop kind of like a CRUD application. Now I'll explain this very, very soon. So what we're trying to do, right? Let's create a to-do entity to start out. So to-do, and it's going to extend our special like super class, which will make persistence super easy. We'll see how that works, annotated with entity. And I'm going to go ahead and add a few fields in here, right? So I'm going to say public string title. I'm going to say public string URL, public Boolean completed, and public order, int order, right? So the order with which like tasks are supposed to be completed. I'll add a minimum order. So the minimum order here is supposed to be like 0. If it's not 0, then we're not supposed to accept this input. And the column is, I've named it ordering in the database. Now, this doesn't do much, right? This is just an entity, Hibernate entity, a little Quarkus magic to make the persistence simpler. We'll see that. And I've started dev mode, so Quarkus is already running. And if I refresh the browser here, I'm not going to see anything, right? Oh, I saw something great. I'm using the wrong Java version. So Quarkus can't really save me from that mistake. but I can save myself. I'll use Java 17, start again, and let's hopefully this time things will be better. And okay, so refreshing, and obviously I haven't exposed my to-do endpoint, right? So I'm not going to see anything here. Now what I have to do is I have to expose it. So let's go and add it. Add a way to expose it. We'll do to-do resource because we're going to expose this as a JAX-RS resource with REST Easy Reactive. So as I said before, REST Easy Reactive is our new implementation of JAX-RS. But it follows, it implements the specification, so all the annotations you already know and the programming model you already know are there, but we have a lot, I would say, of extra functionality to make it a lot simpler. So I'm going to say list to do list, and I'm going to say all here. My goal is to show the list of all to-dos, and let's see how that plays out. To do list all, and I'm going to refresh, and there they are, right? Okay, so there's a lot to unpack here. You're probably asking, okay, where did you configure the database? Why did all this stuff show up? Where was the data that I showed here, right? You didn't show me anything. All you showed me was that you have Hibernate RM and JDBC. Well, let's look at the configuration, right? So the only configuration I have here is that I'm telling Quarkus to drop and create the database, right? So this is just typical for development, obviously not for production. So how does Quarkus actually know what database I'm talking to, right? This is weird. Well, if you were very watching closely to the output of the code here, you might have seen that somewhere it says here, dev services for default data store PostgreSQL started. What does that mean? It means that in dev mode, when you have not configured a database, right, so there's no JDBC URL here, then Quarkus automatically knows that, you know what, I'm going to configure a database for you, and you can go ahead and while you're developing, you use that. And how does it do that? It integrates with test containers. Test containers obviously being the amazing library that makes working with containers a lot easier. So what is that? We have this, but let's look behind the scenes to like Quarkus. What does Quarkus actually do to enable this, right? Let's look at this terminal down here. The terminal says, we'll show some more options here, but let's look at the H for more options. I hit H, and it says open the dev UI in a browser. So let's see what the dev UI does. The dev UI is basically a console for the Quarkus application that runs in dev mode, and it gives me a view of the application of what's going on inside, right? And not only does it do that, it allows me to change a whole bunch of things. So now I see in the first, like, let's say card here, it says dev services. Well, let's open that up. And we see that for Postgres, what we did is that we launched a container, this container, the Postgres 14.2. We exposed the port, the 5432, as this one locally. And when we did that, we also passed this configuration to Quarkus, right? So this is the configuration that you would have had to write on your own if you were going to start the database and actually start the database on your own. But Quarkus did all that for you, right? Just by knowing that you're going to use Hibernate and you have not configured a database, it configured all this stuff for you, and it started it actually started the database for you. So now I can work with Hibernate and continue writing features for my application and not care about all this plumbing that's going on behind the scenes, right? And the same, Quarkus does the same for a whole bunch of other sources like, let's say, Kafka or RabbitMQ, all sorts of databases, message brokers. We have the same functionality for all of that. MongoDB, Redis, all that cool stuff. Now, so let's go and try and write some more code, right? So let's say I have this to-do resource here, and I want to start testing things, right? I don't want to just hit my browser and see that everything works. I want to actually test stuff. So let's go and do create test, and I'm going to say this is a Quarkus test. What that does basically is it tells it it tells JU to integrate with our Quarkus testing framework. And I'm going to say test all. And let's see, I'm going to say test here. And I'm going to press this button that says press R to resume testing. So now what this does is that it looks for tests that I've written, which I haven't done yet. So no test found. Let's go ahead and start writing something. I'm going to say given. So this is Rest Assured. Rest Assured is a library for it provides a DSL for testing against HTTP endpoints. So I'm going to say content type JSON. Now I just want to get everything. So I want to do when get API, because API is the path I specified here. When I do that, then I expect, hopefully, status code to be 200. And now let's see what happens here. So look at this output, right? Look at the magic that happened here. Basically what happened is that I wrote a test, then I took my hands off the keyboard, I just clicked on the console, and what Quarkus did behind the scenes is that it figured out that I wrote a new test, it executed the test. Not only that, it also started a second database against which the tests run. So the same way we configured the database for our dev mode, we're configuring a test for the test mode, right? And that means that is done because we don't want our testing code to interact with to be interleaved with the actual development code. Now, let's say I had written this wrong, right? And I wanted to say status code 201. I would have seen a failure like this, right? Because my code is actually returning HTTP 200, but the test is verifying 201. Now, I'm not sure that you've seen what I'm actually doing here. There's no magic, right? I'm just hitting code, writing code, then clicking on the console, and Quarkus is automatically rerunning all the tests for me. I have not pressed any buttons. I have not configured anything beforehand. This just works. And this is what we call continuous testing, right? The same way we have the dev mode where you write code and things show up in the browser. Now we also have the continuous testing mode where you simply write code, you write tests, your tests run in the background, everything's magic. And let's say I wanted to do some like TDD style development, and I wanted to say test like failed add. I want to add a method. Sorry, I want to add a to-do, and I'll say given content type JSON body. I'm going to write some Java 17 here. This is great. I mean, actually being able to do this in Java after so many years feels awesome. And what I'm going to do, I'm going to add a title, test. I'm going to say completed, false. And I'm going to say order, which remember the order was supposed to be, the minimum was 0, right? So I'm going to go in my test and I'm going to say order -1. And now I'm going to, when post, then let's say status code should be 201, right? So again, I just wrote code, I exited to the console, Quarkus ran the code, the testing code, and it saw, this doesn't really work, right? You wrote something that got 404, but it's supposed to get 201. Well, I made a mistake initially because I should be posting to API, so I'll change that. But again, things fail because now I'm getting 405. I have not implemented the post method anywhere. So let's go back and implement that. And if I go here and I say public, let's say REST response to do add. Oh, actually, I called the test failed add, but let's rename the test to proper add. I don't want it to fail. This test valid add? Because I'm actually, no, yeah, let's do valid first. Okay, so I'm expecting 201. I'm implementing post here. And what I'm going to do here, I'm going to get valid to do, and I'm going to persist it. So to do, not this to do persist. So this is this comes from the panache entity that to do was extending. So I just call persist on the thing, and magically this should work. And I'm going to return a REST response status not accepted, created, and to do. I'm going to go back here in the console, run it, and let's see what we got. We got 500, and it's telling me that, oh yeah, you have not added transaction notation. My boss's boss, who's like a huge transaction fan, would be very, very angry. So let's make him happy by adding transactional that he implemented. And now the tests work, right? So all I did was added code here. I just went back to the terminal, code runs, right? Let's do it the other way around again. Let's add a failing, something that should fail. Well, that should test that an invalid to do does not work. And I'll go here and -1, and I'll say 400. I expect HTTP 400. Go back here. Now, ran 3 tests, as I expected, didn't work. Worked like a charm. This looks great, right? But some of you are like, I don't want to use the console. It's too cluttered. It's too old school, whatever. Okay, that's fine. We can go back to the awesome Dev UI, right? And in the Dev UI, you see this down here. Well, you can't really see it because the colors aren't great, but I'll open it up here and things will be visible a lot better. Now, here are all the tests that Quarkus actually ran in the same, in a different form from the UI. And let's say I made this fail. I go here, everything continues to fail. Right now, this is just too small. I'll make it a little bigger. All the output I got on the console, I got it here magically, right? And I didn't refresh or anything. I just fixed the code, ran it again, everything just works, right? So this is what we call continuous testing. It works with the dev mode, and of course with the dev services, right? So again, for testing, I did not configure a database anywhere. Quarkus just spun it up for me, and all these tests just work against that test database. So it allows you to write stuff very, very, very quickly. Now, we don't have much time, so I seriously doubt I'm going to have time to do the Kotlin demo. Let's at least try to do the reactive stuff. So I'm going to change my dependencies to, let's see, we're going to call reactive PG client. So I'm going to use a reactive Postgres driver, and I'm going to use Hibernate Reactive, right? So my goal here is to convert what I've done here from all the blocking code to reactive code. Now, how's that done? The only thing I need to change here for my entity is change from Hibernate ORM panache to Hibernate Reactive panache. And let's see, ambient Quarkus Dev. Let's see how this turns out. Something is not right here. Difficult, unable to, well, let me see, clean. Okay, so there's probably there's a bunch of failures here. So let's get rid of these two, right? I'll just get rid of this. So there's nothing here. I'm going to start in dev mode. Obviously, all tests should fail since I haven't implemented anything. And tests are obviously, again, database starting up because I haven't configured anything. It works out of the box with Hibernate Reactive as well. Let's resume testing. So I should execute the tests I wrote before. Hopefully none of them will pass. That's what I'm expecting at this point because I haven't implemented anything. And yes, they all failed. 3 tests failed, right? So now in the very few minutes we have left, let's try to implement this. And so Hibernate Reactive uses some reactive types to return the results, right? When you're doing reactive code, you're never returning the actual result. You're returning something that represents the result in the future. And the idea is that you do this in order to not block the thread that is actually making the call, right? So in this case, we're using our own implementation of reactive streams. So we're using a uni. So for those of you who are who know like the Spring ecosystem, a uni would be analogous to a reactor mono, right? It's the same thing. So what I'm going to do here is I'm going to say uni of list of to do, and I'm going to go all return to do all list all, and again this is a get, and let's see. Yes, this is Java, so I still need semicolon. Okay, so now the first test passed, the other two failed. The first one being the list all. Now the other two, which because I haven't implemented the add thing, will fail. So now let's try and implement that. REST response of to do. So REST response basically is a way to encapsulate that I'm returning both the result and I want to set some like HTTP headers or HTTP status code or whatnot. So I'm using REST response here, and again with a uni because I'm returning this in the future. Valid to do. Okay, so return. Now I need to persist this, not this, because that won't make my test pass, that's for sure. I need to persist this. I'm going to actually add a hint to the type system because Java's generics are always very, very fun. And I'm going to map this to a REST response status, status not accepted, created, T. And here I haven't done anything with transactions, and transactions work a little differently than the annotation style. Basically, whenever you're doing reactive APIs, some annotations might work, some might not. It's a little weird because you don't have, there's no way to like invoke something around a reactive chain. So what we find better is to use this method here, which is basically just starting, the chain of the chain we're creating here for the persistence is going to be wrapped inside a transaction. And let's see, hopefully that will work. It will not. And no, okay, persist. I think I'm going to have to write this. I'm going to extract this. Yes, let's take this out and write this from Panache with transactions. So I'm going to go T home return, and let's see how this works. And this doesn't like this here. And what's it saying? Compatible types. T. Okay. Persist map. Let's do this again. Excuse me? I can't really hear you. I'm sorry. Okay, hold on. Let me persist map. And let's try this again. Return. Yeah, this is it's wonderful trying to debug lambdas. Oh, I already have one? Oh, wow. It was that simple? Oh, thanks. Thanks for that. Great. Well, actually, the transaction doesn't have this. Yeah, anyway, I could have done this. Yeah, so this should just work. This hopefully will get me where I want to be. It does not, and oh, right. This needs to be a post. So it failed miserably before, but now everything's passing, right? So I just wanted to show you, I didn't see how many minutes that was. That was covered. 5 minutes, okay, great. I just wanted to show you how we could convert like an API from a blocking API to a reactive API using pretty much the same primitives. Obviously, the API changes a little bit, but again, you're using the same JAX-RS implementation. You're just returning different types. You're using a Hibernate reactive, which is based on Hibernate RM, so you're not completely switching your model. And not only that, you can mix and match this reactive stuff with the blocking stuff inside the same application, right? So as opposed to, let's say, what Spring does with Web and WebFlux, where it's a totally different world, you can't mix them. Here, you can mix the same blocking APIs, non-blocking APIs in the same application, no problem. You can choose whatever you want for your use case, right? And again, obviously, this continuous testing stuff is awesome. Now, I was going to do a Kotlin demo with Kotlin coroutines, but that's not possible in like the 3 minutes I have left. So let's finish the slides with a note about Quarkus performance, right? A lot of the times, the way a framework, how well a framework can perform under load is not really a primary concern for people that are evaluating frameworks or actually they're testing their stuff. But it's very, very important when you're actually, when you have an application that you are going to send to production and you want it to be able to respond well, perform well under high load, it's very important that the framework actually gives you the performance that you need. And now let's see over the past, let's say 2 years, how much Quarkus performance has improved, right? So this first slide shows like a baseline of where how much performance we could get with a version of Wildfly, right? And then we're comparing, this is probably like 2 years old or something like that, or a year and a half. We're comparing that baseline with Quarkus, the blocking style for Quarkus version 111, so this is a year and a half old, and some other APIs here. Now, it's not exactly evident here, but these two top bars are Quarkus reactive on top and Quarkus blocking second one. So it already performed better than all the other stuff out there. But let's see where we are now, right? Where we are now, this is snapshot, but it was like, it says snapshot because we were testing this from main and not the latest release, but it's very close anyway. Our performance has improved vastly. Oh, and I should say that this is for the Tech and Power benchmark. Tech and Power, I think, is like one of the most well-known load testing benchmarks out there. It's releasing a new round very, very soon, so you'll be able to see the updated numbers. So Quarkus blocking already like very much better than what it was before, and obviously better than anything else. And the reactive style, again, it scales a lot better than the blocking one. It basically gives you the more throughput than the blocking one. So depending on the use case, you might want to use that or not. Now, this is where we're actually showing how much of a difference we've achieved over these past 2 years. These are the blocking. It was the green one, and it has moved up here. And the reactive one was the red one, has moved up here. So again, we did a lot of work on the performance, and the latest Tech and Power benchmark pretty much shows that. And that's all I had. I think I'm almost out of time. These are like some links that you can follow to learn more stuff. And do we have time for questions or no? One question? Oh, okay, cool.
Any questions? See some raised hands, maybe? If not,
excellent.
Thank you so much.
Thank you.
Yorgos.
Thank you.